Check, mic check. All right, everybody, good afternoon, good evening. We are live. It is October 23rd, 2025 today. Let's wait for folks to chime in. I'm going to get 40 minutes on the clock today. Question of the day, as usual, same as always. What topic should we focus on today? We're going to do 40 minutes on the clock today. Let's do 45 minutes on the clock. It is 6:03. And let's change this real quick. What topic should we work on today? What topic should we work on today? And Willow, Mudkips, welcome in. And 45 minutes on the clock. Poll is active. Question of the day. What topic should we work on today? Is it going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus? You can also change it to general mathematics. We haven't done that much math in quite some time. Folks that are just joining in, welcome into the chat. We are just getting started for today. Happy Thursday, October 23rd. My friend says number one, first one in the poll. Make sure you vote on the top left-hand side of your screen. Vote. Vote on this top of screen. All right, what is good, everybody? We are just getting started today. Got lots of topics to focus on today. I'm going to go ahead and check the Discord in just a moment. Guys, anyone that is just joining in, welcome into the chat. My name is Dr. Andrew. Guys, how's everyone doing today? Is everyone surviving the quarter? I know right now it's midterm season because it's October vibes, so I know that there's lots of exams, lots of midterms, exam, tests, quizzes. How are we doing? Are we still alive? Are we still living today? If not, don't even worry because I go live every single week, Monday through Thursday, to answer your STEM questions here. So let's see what we should focus on today. Is it going to be general chemistry, organic chemistry, physics, or calculus? Charles, Barbara, welcome in. 87% on my Gen Chem midterm. Wow, W, that is pretty solid. Bubba says math, calculus, D. Make sure you vote on the top left hand side of your screen, twin. Make sure you vote on the top left. So tap the left side here. Nana, good to see you. How are you doing, my friend? I just texted you. Guys, if we should do general chemistry today, make sure you vote for general chemistry up on the top left. Bubba said got 32. I hope that was not a percentage. I hope that is a score out of something higher. Guys, welcome into the chat. We got one vote each, one for Gen Chem, one for physics, one for calculus. We got 45 minutes on the clock today. I'm going to wait just a couple more minutes before we get started. I'm going to wait just a couple more minutes just for today. LMAO, it's a percentage. Okay, Bubba, don't even worry because guess what? On some of my worst exams, you know what? Guys, did you know that on my Gen Chem exam, I got as low as a 25% on my Gen Chem? And on my engineering exams, I remember getting back my score and I got 17%. Oh my gosh. And yet I still got through my degree and my PhD. Okay, guys, so if you think that grades are super important, yes, they're important, but they're not going to make or break you, okay? Grades are just one aspect of learning here, guys. I'm going to wait just a couple more minutes before we get started. As we can see, we have a poll active today. Same question as usual. What topic should we work on today? It's going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus. Guys, I think I'm going to log into my other account so I can vote because we haven't done math in a while. So I kind of want to show math some love. Let me see if I can log in here. Shucks, I'm not logged in here. So maybe next time I'll log in here. Rest, good to see you. How are you doing? Rest, patiently waiting for calculus. I know we haven't done calculus in quite some time. Absolutely, there's hope. There's always hope. Okay, guys, remember, I always struggled so much. Guys, anyone that is just joining in, welcome into the chat. I'm going to wait one more minute before we get started and log in today. We're going to wait one more minute before we log in and get started today. So we got 40 minutes on the clock. So if you want people to vote, if you want to do your topic, make sure you invite your friends and make sure you invite them to the live stream. Send it right now because you got 40 minutes to lock in your vote. Whoever's the winner after 40 minutes, that's what we're going to do for another hour. But for the first hour, we're going to see what we do today. Joshua, thank you for your voting. If I had a good algebra foundation, I wouldn't be struggling. That's right. So if you have struggles with algebra, that's going to cause you some troubles with calculus. So that's why I kind of want to do math today, because I feel like algebra is the hardest part sometimes. Joshua, welcome in. Alina, good to see you. Okay, guys, remember to vote on the top left-hand side of your screen. So tap the top left-hand side of your screen. Alina, thank you for the suggestion. We can do Hess's Law Twin if that's what's going to be the winner. We might get started with that here today. And I'm going to wait in 5 seconds. We'll get started in 5, 4, 3, 2. And perfect, guys and gals. Welcome into the chat. My name is Dr. Andrew Sanchez, PhD in Chemical Engineering. As you can see, we have the poll up active on the screen today. Question of the day: what topic should we work on today? Make sure you vote on the top left-hand side of your screen. It's going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus. Anyone that's new here, do me a big favor and comment the word new so that we know that you're new. And if you've been here before, make sure you comment the lock emoji, because you know we're about to lock in. That's right, we're going to do a full 2-hour session today answering your STEM questions. I go live every single week, Monday through Thursday, 6 o'clock PST, 9 o'clock EST, to answer your questions for math, chem, physics, and more. So that's right, if you're on your bed, get off your bed. If you don't have your notes out, get out your notes, get out your calculator, get out your periodic table. All right, and guys, before we get started, I just want to introduce myself. Once again, my name is Dr. Andrew Sanchez, PhD in Chemical Engineering. As you can see here is my website. Go to engineeringminds.co, where you can see all these tons of goodies for you. Working on lots of goodies here today, so if you go to the link in my bio, go to engineeringminds.co. Number 1, you can sign up for tutoring. I offer tutoring for various STEM subjects, including math. So whether you need algebra help, trig, pre-calculus, calculus 1, 2, or 3. Physics, college physics, AP physics, or calculus-based physics. AP Chem, general chemistry, or organic chemistry, and engineering, I got you covered. So you can sign up for a free consultation call at the link in my bio by clicking the link, or go to engineeringminds.co. Next up, you can explore the resources page. So click that link that says explore resources page. We will have tons and tons of goodies here. I'm going to start building these out. I'm going to have hundreds, if not thousands, of problems for math, physics, chemistry, engineering, computer science, and biology. Super excited to be building that out. Next up, we also have the join Discord community. So anyone that is in the Discord, please comment the word Discord or say that you're here. Why should you join? Because we are building an active community of STEM lovers, engineers, and future doctors. So you can ask questions, interact, and jump in to meet other STEM majors. And last but not least, if you want to ask your questions for today's live stream, make sure you click that button that says TikTok Q&A. All right, guys, so we have our poll active. So if you want people to vote, we have the question of the day: what topic should we work on? And so you're going to tap the top left-hand side of your screen: A for Gen Chem, B for Organic Chem, C for Physics, and D for Calculus. So you have 37 more minutes to vote. And I'm going to go ahead and check the Discord to see if we have any questions in the Discord. Right now, our general chemistry is cooking as usual. Gen Chem has been cooking lately. So again, if you want people to vote, make sure you vote there. And so I'm going to go ahead and check the Discord. I don't see too many questions, so I think we're going to go ahead and get started with the TikTok Q&A section. And let's see what we have here. So since Gen Chem is currently winning, we're going to start with one topic for Gen Chem and then one for Calc, because I see a lot of questions for Calc today. So guys, I'm seeing a lot of questions for Calc today. So I think what I'm going to do is I'm going to start with Calc. And if Gen Chem is winning, then we'll do Calc the first hour and then Chem at 7 p.m. So guys, how about this today? What if we do this, because we haven't done Calc in a while. So here's going to be the tentative schedule. So here's what we're going to do today. Here's going to be the tentative schedule. Let's bring this down. Today is October 23rd. No, you. Today is Thursday, October 23rd. So we're going to do calc review. And then at 7 o'clock, we're going to do whatever is the winner. Okay? Most likely is going to be Gen Chem, because Gen Chem been cooking it up, or OChem. OChem's been on the top as well. So how does that sound, my friends? If this is a good plan for today, do me a big favor and drop a thumbs up if everyone agrees with that. So you can either stick around for the hour and get your questions for calc, drop them down below, or you can come back at 7 o'clock if you want to do the Gen Chem review. But whatever is the winner, I have to prioritize the winner, guys. And the reason I'm doing this is because we haven't done calc in a while. Bubba says W, Rest says yes. Guys, if calc is good for now, go ahead and comment W. And my next question for you, so I think that's what we're going to go ahead and do, guys. So we're going to do a calc review for today. My next question for you, my friends, is going to be, do we do calc 1, 2, or calc 3? Are you guys in calculus 1, 2, or 3, or AP calculus? And which topic should we do? Should we do derivatives? Should we do integrals? Should we do trig review? Should we do optimization problems? Should we do word problems? What topic exactly should you focus on first? Let me see what the chat said. Let's see what chat said. So let's get out that schedule now so people can see that. And once again, if you need tutoring, don't be shy to ask me for help, okay? Don't be shy to sign up for a session at bio. Okay, Alina, I'll see you soon. Calc 1. Okay, so I'm thinking we're gonna do. Okay, what is Unit 2, Rest? Unit 2. What is Unit 2? One-sided derivatives. So I'm thinking we're gonna do derivatives probably because that's Calc 1. When derivatives don't exist and the one-sided derivatives. When derivatives don't exist and one-sided derivatives. For tutoring, I have different rates depending on what you need, twin. So if you need tutoring, make sure you see the rates. All the information is in the link in my bio, engineeringminds.co. The 4 ways derivatives don't exist and one-sided derivatives. I'm afraid I don't quite know what you mean, but I think I have an idea. I'll be right back. Let me get my reference text. Be right back. Okay, so I think what we're going to do is do some basic examples. Let's see if we're all on the same page here. Okay, and we're going to basically do cusp, corner. Let me add colligative properties to the list so I can add just all the, I can just add all the topics that are requested here. So I saw basically colligative properties, and then I saw Hess's law. Okay, so cusp, corner, and vertical tangent. And Rest, if you're in the Discord, best bet is if you can drop some in. Guys, I'm going to go ahead and do a quick review. Let's see if I can find some on my own end here. And I'm going to go ahead and hide this for now. Guys, let's go ahead and just start by reviewing the general derivative rules. Let's see if we're on the same page here. So is everyone familiar with each of the rules? For instance, the power rule. So we're going to do a Calc 1 review, Calculus 1, and let's just make sure we're all on the same page here. So does everyone know all the rules at the very least? Okay, are you at least familiar with all the rules? So for instance, if d dx of my function, okay, f of x raised to some power n, what would this be here? What would this be? Is everyone familiar with the power rule, right? Okay. Yeah, we can also do related rates. Okay, so you're in the Discord. Can you drop it in hashtag math, Rest, if you don't mind? Drop it in hashtag math. Let me know when you do, and we'll do that first. We can definitely do related rates as well. Okay. So basically, my first rule is called power rule. So power rule is going to be, if I take the derivative of some function, I'm going to say that's n. I bring down that power here, right? N times that function raised to the n minus 1, right? This is going to be our first rule. This is our power rule, right? So is everyone familiar with that? Okay. Then what I'm also going to do, guys, don't forget the chain rule. So for instance, if I have the chain rule, let's do the chain rule here. If I'm saying f of g of x Okay, that's gonna be my derivative f prime of x times g of x, okay, plus g prime of x times f of x. Okay, that's gonna be my, no, excuse me, I just did the product rule. Hold on a second, I just did the product rule. With f prime of x times g prime of x. I'm gonna do f prime of, let's see, how would I write this? I'm gonna call this f prime of g of x, there we go, times g prime of x. Okay, so this is gonna be our chain rule. So if everyone's agreeing with that, hopefully everyone agrees with that. And then next we can do our product rule, which is a product of two functions. This is what we need. This is gonna be our main formulas here, right? If there's any rule that you need to go over, please let me know. This is your chance. This is your opportunity to go over these rules here. So this is gonna be the product rule. And last but not least, we're gonna have the quotient rule. So if I have f of x divided by g of x, well, my quotient rule is going to be f prime of x times g of x minus g prime of x times f of x, just like my product rule, divided by my g of x quantity squared. Okay, so if everyone is so far so good here, go ahead and do me a favor and drop a thumbs up down below. Okay, if you're agreeing and you're understanding this, or this is helpful, just go ahead and drop a thumbs up to make sure we're all on the same page. You can definitely do related rates. This is super cool. I'm in EE finishing my master's. Oh, awesome. In medical device engineering, appreciate you. Welcome into the chat. Big Hearn shouts out fellow engineer. Okay, Rest has just sent it. So Kaylee Bubba, thank you for the thumbs up. So I'm assuming that everyone's comfortable with this part so far. And if you're not, I promise to get some videos on these out soon. Okay, thank you, Rest. So I'm gonna go ahead and pull that up from the Discord. Okay, I'm gonna pull up this question of the day one more time. So make sure you vote on the top left hand side if you haven't already. Let's go ahead and pull up those questions real quick. Okay, whoops. Went too high. Question of the day. Okay, so make sure you vote there. All right, so what we're gonna do here is gonna be our, let's see, in hashtag math. All right, thank you, Rest, for dropping that in. Okay, so we have this equation here. Hey Twin, how are you doing? Twin, we're gonna do calculus for now, and then in 40 minutes we're gonna do chem. But make sure you vote on the top left, okay? Make sure you vote on the top left-hand side screen. So, okay, we have basically, okay, g of x, okay, I think this is it here. So I think this is what you were asking about. Thank you for that, which, by the way, guys, someone just dropped a question in the Discord. That's one of the best ways to drop in your questions down below to ensure that we can help you out. And so if you want to join the Discord, it's totally free, guys. Just don't join the link in the bio. And if you're in the Discord, yeah, just introduce yourself and we'll help you out. You can ask questions, meet other people, talk to me or any other members. Okay, it's a supportive community that we're building out here. So Rest, let's just make sure that we're on the same page here. Just to make sure I'm reading your writing here. And what is the instructions here? So is it x, what does that say? 1, is that x plus 1? What does that say here? C equals 0. Can you please clarify what is the question asking here? Is that 1? That looks like a 1 times 1 to me. So I'm like a little bit, okay, so g of x equals 1 times 1. The question is asking, okay, so the question, so you said that. The question is asking, okay, the question is asking the value of the derivative as it approaches c. The value of the derivative as it approaches c. What is the square root? Sorry, that's the absolute value of x. Oh, the absolute value of x. Oh, okay, got it. So the absolute value of x, right. And so we have, someone said quantum mechanics, absolutely. Okay, absolute value of x. I thought that was a 1 times 1 as well for a sec. Okay, cool. So we basically have the square roots of the absolute value of x. All right, and so we have to do, let me write down the question one more time. basically says the value of the derivative, basically find g prime of x, g prime of c as it approaches c. The value of the derivative as it approaches c. Okay, so first things first, we gotta take the derivative, but the problem is it's non-differentiable at c equals 0. So we're gonna have a cusp. So we're gonna have a cusp here because it's non-differentiable. So that means we can't take the derivative of a cusp. Let's write that down. We can't take, okay, the derivative of a cusp. Does everyone understand that? Does everyone understand that? If everyone understands that, drop another thumbs up. And if you do, let me know what that means. Someone comment down below, why is this true? Why is that true? So why can't we take the derivative of a function at a cusp? Why is it non-differentiable at that cusp? Okay, so someone comment down below why we can't differentiate at that cusp. Okay, so we need to basically identify where it is differentiable. It's going to be differentiable to the left and to the right of the cusp. Okay, JJ says thumbs down, good to see you. Okay, so that means that we do not understand that. So we can't take the derivative of a cusp because the derivative, exactly, the slopes are different on each side. Okay, so if I were to draw a picture of the absolute value of x, okay, we have two different derivatives here. So this is my absolute value of x, and so on the left-hand side, my derivative is negative. My slope is negative here. On the upper right-hand side, my slope is positive. So that means that I cannot differentiate at this point. So our job is to essentially determine the derivative to the left of c and to the right of c. Okay, so we're going to take two derivatives. First, we're going to plug it in for anything to the left of c equals 0, and then we're going to plug it in to anything to the right of c equals 0. Okay. Okay, so let's write that down. So before we get started, let me know if there's any questions before we do that. Okay, so I'm gonna basically erase this, I'm gonna erase this, and we're gonna take the derivative. So remember, we're gonna rewrite our square root function as a square root. You guys remember, I can help you out with math. If you need math tutoring, I definitely got you. Okay, so we have the square root of the absolute value of x. Okay, and we're gonna basically write that as a power to the 1/2. Okay, so if I differentiate, I take g prime of x, I take the derivative with respect to x, that's going to be 1/2 times the absolute value of x. Okay, 1/2 times the absolute value of x. Okay. Okay, I can't write today, guys. My pen is all janked up. And that's going to be to the minus 1/2. That's going to be to the minus 1/2. So if I were to rewrite that, that's basically 1/2 times the absolute value of x. And all of that is going to be square rooted here, just like that. I'm going to rewrite that as a 1/2 times the square root of the absolute value of x. Okay, so if this is making sense so far, do me a big favor and drop another thumbs up, chat. If you're agreeing here, do me another big favor and drop a thumbs up if this makes sense. So how do you know to take the left and the right? Because it is non-differentiable, so that's what we need to do. We need to get a value left of this number and then a value right of this number because it is not differentiable at that point. I sometimes look at the step 1 and then step 2 derivative, have no idea where some numbers came from. Got some of it now. Okay. The second step, I like it when people say sorry and then ask a question. So like, don't be sorry, just ask your question. So the second step is basically a negative. So my second step is recall from algebra class. Recall that anything to some constant. Recall that anything to some negative constant, okay, negative a, is equivalently 1 over x to the a, and anything raised to a fraction is, guys, I need to get a new pen. This pen is all janked up here. 1 over a is 1 over 8th root of x. And similarly, so therefore, x to the negative 1/2 is 1 over square root of x. Okay? So that was that part over here. And so now we're going to basically analyze this here. So we got to do the, we got to assume the derivative exists. So I got to do my definition of the limit. I got to do the definition of the derivative from the limit. So the definition of the derivative from the limit states that my g prime of x is the limit as c, I'm going to call it c approaches 0. I'm just going to call it h approaches 0 because that's the standard. I'm going to do h approaches 0 of what? Does anyone remember the definition of the derivative? It's going to be x plus h, okay, minus g of h all over h. Now, now my h is 0, okay? So my h is 0, so I'm going to basically plug in the limit as h approaches 0 of g of x minus g of 0, because my h is 0, and great. So now I'm going to apply that for my specific function. What's my function again? It's the square root of the absolute value, okay? Anytime. So what should I do from here? I'm basically going to get rid of that. I'm going to say that's going to be my g of x is my square root of my absolute value of x. But that's going to be square root of absolute value of, that's going to be g of h rather. Absolute value of h here minus 0, which is just going to be 0 divided by h. So I have the square root of h, I have the limit of the square root of h, absolute value of h divided by h. Okay, hopefully I didn't lose anyone here. I'm basically just applying the definition of the derivative here. Okay, how advanced math do I need to be to learn physics? What physics would start? You definitely need algebra and trigonometry. You also need calculus and differential equations. What other physics do you want to learn? You're also going to learn some advanced functions like Hamiltonians and Lagrangians, so that's going to be some advanced calculus. Cool. So this is going to be the, let's do the left-hand side and the right-hand side. Let me know if I lost anyone here. This is going to be my definition of the derivative. Why not use the one-sided limit theorem? Okay, we can probably do that. Okay, what are some of your favorite online resources? Guys, what are some of your favorite online resources? For me, I'm a big Khan Academy guy. So I'm a big Khan Academy guy. So I'm going to do the left-hand side. Okay, and I'm going to basically do the limit as h approaches 0. Okay, this was definitely way harder than I thought. This is definitely a way harder problem than I thought. We have to do some limits here. And so from the left-hand side, if I basically have a negative number, that's going to be absolute value of h is just going to be h. And this is going to be the absolute value of, this is going to be basically square root of h divided by negative h. So this is going to be square root of the absolute value of negative h divided by negative h. Okay, so I'm just going to call this the negative square root of h. Negative square root of h divided by h. Okay, and I got a no, I have to basically take the limit as h approaches 0. I'm going to get negative infinity here. Okay, I'm going to get negative infinity from this part here. Am I making up those names? No, absolutely not. Hamiltonians and Lagrangians. Yeah, that's some advanced physics there. Yeah. Those are some calculations we can talk about. Yes, they're real, Makaya. I'm paying $5,000 to the first 5 people to message me. Struggling. I don't know what you're talking about. Okay, so that's going to be the left-hand side. So let's try that again. Okay, and then that's going to be, let's do the right-hand side. So we got to do that again. Gosh, I hope there's an easier way to do this, Russ, because I'm doing it the long way. And I don't know if there's anything that we can do here. So for the right-hand side, similarly, that's just going to be a square root of the absolute value of h. Should be positive infinity. Okay? So, therefore, the derivative does not exist. So we kind of proved it because we got 2 different limits. Okay? I wish there was an easier way. Maybe there's an easier way, guys. If there's an easier way, let's do a recap of what we did so far. Basically, we had to differentiate this at c equals 0. But the problem is we have the square root of the absolute value of x. So therefore, we had to determine if there's a cusp here. So if we determine that we have a derivative here at this cusp, then that's going to tell us that the limit does not exist. Okay? So it's not the LeBron James equations. The LeBron James equations. Yeah. It is. You're right. Okay, Russ, did this make sense? Let me know if that made sense here. Okay, so we determined that the left-hand side is not equal to the right-hand side, so therefore the limit does not exist here. Okay? I think he used the one-sided limit definition of the derivative. So let me see what you're saying here. The one-sided definition of derivative. So one-sided limit theorem. That's probably going to be easier. So f prime of a, which we did, is the limit as x approaches a. That's kind of what we did. Because that's the definition of the derivative. Okay? Oh, but you did x minus a. Interesting. So let's try it that way. Let's see if that's going to be easier. So using the one-sided limit theorem, if I go ahead and plug in my my f of x one more time was the absolute value of the square root of the absolute value of x, then I'm going to plug in my function here. Okay, where a equals 0. So take the limit as x approaches 0, as a approaches 0 over x minus a. Then that's still going to be the square root of x over x. So we're going to get the same thing. We're going to get a separate number for positive and a separate number for negative. So therefore, the limit does not exist. Okay? I think use one-sided limit. Could you explain an example of inverse functions with derivatives? Of course. So I think the next one, let me know if that was helpful. Okay, the next topic that someone said was, what was that other one? It was basically related rates, right? Guys, I think the next topic is going to be related rates. So if we're going to lock in for related rates and that's a good idea, go ahead and drop a thumbs up. If related rates is a good idea, go ahead and drop a thumbs up. Okay. Cool. Ooh, partial derivatives. We can definitely do partial derivatives, guys. Should we switch it to Calc 3 next? Guys, remember, we have the poll active. We still got 10 more minutes on the clock, and then we're going to switch gears to whoever is the winner. So make sure you tap the top left-hand side of your screen, and then that's going to be the next topic we do for today. So do you want to do Gen Chem, vote A? Do you want to do Organic Chem, vote B? Physics, vote C, and then keep it to calculus. Make sure you vote for D. All right, and then we're going to switch gears in about 20 minutes here. Okay, so we're going to do related rates here real quick, and then we'll do inverse functions. And then Arab Prince, if you want to go ahead and drop in your questions in the Discord, please do so. That'll be the best way for me to help you out. Okay, so the main related rates one here is going to be this one here. Okay, the main related rates is going to be this one here. So it's basically going to be like a ladder. It's going to be like a ladder. And so the ladder is leaning against the building. Okay. And so let's see, they're going to give us a couple values. Let's see if I can remember what they might give us. Okay, I remember we got to solve for dx dt. And so what I want you to do is I want you to visualize, we're putting these two dots here. I'm going to put this dot right here and this dot right here. So I'm going to put this dot A real quick, and I'm going to put this dot B real quick. So this dot A, as the ladder is falling down, which direction, as the ladder is falling down, which direction is A going to go? Is it going to be dy dt? Is it going to be a negative dy dt, or is it going to be a dx dt? So, guys, I kind of want to end the poll early so I can ask another poll. It's okay. Guys, let's just do comments today. So, if you think that our A is going to be a negative dy dt, you're going to vote for a happy face. If you think that our dx dt is our A, vote for a crying emoji. Okay? So, guys, our A is going to be moving as the ladder falls down. So, if you think that the point A is going to be in the negative dy dt direction, vote for a happy face emoji. Okay, good. Good. So Arab said happy, Bubba said happy, right? So do you guys visualize that's going to be in the negative dy dt? Okay. And so for our point B, it's going to be moving to the right. Okay. So let's say initially, they give us, let's say initially negative dy dt is going to be, let's say it's going to be negative 3 meters per second. Okay, so they're going to say a ladder is falling at 3 meters per second. And they say that this initial delta x, okay, this we're going to call this delta x naught. Let's say this is like 5 meters. And let's say that they give us the length of the ladder is about 7 meters. Okay? And what we want, they say calculate dx by dt. Okay, so we have this ladder here, and we have the length of the ladder, and all we have here is this equation here. So this is a related rates problem. So how do we solve this, chat? What's the first thing we got to do? How do we solve this related rates problem based on the problem statement here? So they gave us, again, they gave us the falling rate of point A in the top of the ladder. Okay, they give us the initial condition here, and then we want to solve for dx dt. Let's solve for dx dt at, let's solve it for, let's get it at like 0.8. Let's get it at like 8 seconds. So we want the speed dx dt when it's 8 meters away, at 8 meters away. So do we understand the problem statement? Do we understand what the problem is asking? If you don't understand the problem, what the problem is asking, you're going to be basically fried. Okay? Very good. So find the area of the triangle, find the derivative. Okay, we don't need the area, but we're on the right track. Hassan says Pythagorean theorem. So guys, let's apply the Pythagorean theorem here, and let's derive an equation here. What is the Pythagorean theorem, chat? So everyone comment down below, what is the Pythagorean theorem? I'm going to highlight this as my x. Okay, I'm going to call this x, and I'm going to highlight this as my y. This is my y. And then my L is given. So does everyone see this is a triangle here? What is going to be my formula for Pythagorean theorem? Guys, everyone comment down below. What is the formula for Pythagorean theorem here? Okay, so how do I apply the Pythagorean theorem here? I need to do a related rates problem here. Okay, all right, good. So plug in whatever value to an implicitly differentiate equation. Okay, a squared plus b squared equals c squared. Okay, good. So that's not wrong. So that's the Pythagorean theorem. Good, but I need something a little bit more general here. I need something a little bit more general here, guys, because I need to differentiate this with respect to x. So, okay, a squared plus b squared equals c squared. Okay, that's not wrong. Okay, that's not wrong, but I need something a little bit more general here so I can differentiate implicitly, right? This is the difference between calculus and algebra class. In algebra class, we just have simple numbers, but here we got to do some implicit differentiation. Okay, I don't know, man. I'm barely passing calc. It's all right. It's all right. You're doing great. You're doing great. So guys, we basically have our x term. This is going to be a variable. So let's look at the triangle. Is x constant or is x variable? Is x a constant or is x variable? What about y? Is y constant or is y changing? Well, remember, we said dy dt is changing, and then length is going to be constant. So the length of the ladder is constant, right? The length of the ladder is constant, but remember, I got to basically do a variable. I'm going to call that horizontal. I'm going to call that x squared. Okay, good. Both are variables. So x squared, okay, plus y squared equals L squared. But my L squared is a 7. So I have two variables, and I have one, and then I have one constant. So we have a problem here, but we also have a solution. So as soon as I differentiate with respect to time, then that way I can solve for my speed at that point, okay? Let me hold on a second here, because this is the most important part. We got to set up the equation before we can solve the equation. So if we're all good up to this part, drop another thumbs up if we're understanding how we're going to set up the equation here. So if we're good so far here, drop a thumbs up to make sure that we're understanding how to at least set up the equation here. The equation is the Pythagorean theorem for this triangle here. The x is variable. It's going to be changing here. Y is going to be changing, right? Okay, Herb says thumbs up. Perfect here. Okay, perfect. So we're going to basically have thumbs up, blah, blah, good, good. So now we got to differentiate this implicitly. I got to differentiate this with respect to time. So I'm going to take the derivative of both sides and differentiate this implicitly here, right? So the derivative of constant is just 0, so I'm going to cancel out that. All right, so the derivative of a constant is just 0, so I just neglected that constant. So now how do I differentiate this implicitly, chat? How do I differentiate x squared with respect to time implicitly here? Okay, remember, I got to use the chain rule here. So if I'm going to use the power rule first, so I'm going to have a 2 times an x. There's going to be 2x here times dx dt. Okay, times dx dt. That's what I'm trying to solve for. I'm trying to solve for dx dt at x equals 8. So I have x equals 8 here. Okay, so good. I already have this, and this is what I'm trying to solve for. So I'm already making good progress here. Plus, okay, now I got to differentiate 2y. Okay, 2y times dy dt. Okay, so now the small problem here, guys. We don't have y. We need y initial here. How what, my friend? I differentiated this implicitly here by taking the derivative of x with respect to time, and I'm going to set this equal to 0. So we have a small problem because we have our x term that's x equals 8. Okay, in the problem statement it said x equals 8, which I kind of made it up. The problem, and we have dy dt equals a minus 3. So this is going to be 3. This is going to be 3. And so that's going to be our dy dt. So that's going to be 3. Okay? And so the problem though is we don't have our y. So our initial y is basically our y naught here. That's going to be our triangle here. So now let's use our Pythagorean theorem again so we can solve for our initial y here. Okay, so now we need to get our y when x equals 8. Okay, why? Because x equals 8. So that's going to be x equals 8. And then our y is unknown. And then my 7 is constant here. So the ladder is going to fall, right? The ladder is going to start falling. And then at a certain point, the ladder is going to be almost to the ground here. So the angle is changing. angle is changing here, that's going to be my ladder equals, or my length is going to be 7, this is going to be 8, and then this is going to be y. Now the problem is I made up these numbers, so we're going to get some negative numbers. So I'm going to go back here, I'm going to change this 8 because we're going to get some negative numbers here. So I'm going to change this to like a 4. Okay, because we can't have a side. Actually, I think we can. So I think we were safe there, but just in case, because according to the triangle inequality, we can't have the sum of the sides be equal to the let's see, we can't have the product of the sides, or we can't have the sum of the sides be more than the hypotenuse. The sum of the squares of the sides can't be more than the hypotenuse. Okay, so now we have x equals 4, which I just changed that, which I'm going to change that into my x here. Now I'm going to solve for y. So I'm going to use my Pythagorean theorem again. We have x squared. Okay, we have x squared plus y squared. Okay, x squared, come on, plus y squared equals a 7 squared. And so I have my x squared, so I'm going to solve for my y squared here. Okay, oops, this is going to be a 7 squared. And so I'm going to solve for my y squared equals a 49 minus an x squared. Well, my x squared is going to be a 4 squared. So I basically have the square root of 49 minus 16. So I'm going to take that for my y, and y is the square root of minus 49 minus 16. 16, not 64. 49 minus 16. Yeah, because I just changed that. Yeah, right? Yeah, we were going to get a negative number. Thank you. Yeah, I'm glad we saw that. Okay, 49 minus 16. Okay, and I got approximately 5.744, but I'm going to just leave that as, as square root 4. So I'm going to leave that as a square root of 33. Okay, so now I have my, let me take a pause here, guys. Any questions so far? We're doing related rates right here. We're doing related rates right here. So this is my y, and that's going to be my dy dt. I already know that. That's my 3. So let me take a pause right here. Everyone understand this so far so good? Can you move the screen over just a tad? How about that? How about that? Okay. So, and remember, guys, I am recording this entire session. Okay, I am recording this entire session. So I'm going to post this up on my YouTube channel later today. Okay, later tonight. Can you explain more? So what part should I re-explain here, chat? This is going to be my related rates function here. And I have my, basically I have my, my equation here is my Pythagorean theorem here, right? We have my Pythagorean theorem. And we're going to be basically doing our Pythagorean theorem to derive our related rate equation. So right now I have 2x times dx dt. And remember, we want dx dt at x equals 8. So this is effectively what I want. Yes, sir. Grind never stops. Y equals root 33 dy dt. Okay. So I'm going to basically do that here. And I'm going to move that to the other side here. I'm going to solve this expression here for negative 2y dy dt. And I'm going to plug in my negative 3 here. I'm going to plug in my negative 3 here. That's going to be, I meant to say a positive dy dt was a negative 3. So I can basically cancel out my 2 and my 2, and then divide both sides by x. So at the end of the day, my equation is a negative y over x times dy dt. I already have my y, that is a root 33, and my x was given at x equals 8. Okay, so all I gotta do is plug in those numbers here. My dy dt was a 3. So I have my y equals a negative root 33 divided by my x was 8 times a negative 3. Negative times a negative is a positive, so my final answer should be a 3 root 33 over 8. That's my final answer here. And guys, I just made up this problem on the spot, but this is the standard solution here for your related rates problem here. Okay, so that's going to be your standard solution for related rates. Any questions? Once again, I am recording this, so if you want to rewatch it, practice it multiple times, that's going to be our That's going to be the way we do this here. Okay? And guys, we're going to do one more calculus topic. We're going to do one more calculus topic, and then we're going to do basically we're going to switch gears to the winner. So we got 5 more minutes on the clock here. Or let's see, did the poll end? Oh no, the poll ended. Let's see who was the winner, guys. Any chance you can touch on molecular orbit theory if we have time? Guys, we're going to see who's the winner here. We're going to see who is the winner of the poll. So the question was, oh my gosh, we have equal votes. We got equal votes for Gen Chem and Calculus. What are we going to do? What are we going to do? Since we're still on the topic of calculus, we're probably going to do calc for a few more minutes, and then we'll switch to Gen Chem after. But guys, anyone just joining into the chat, welcome in. This is Dr. Andrew Sanchez, coming at you live every single week, Monday through Thursday, to answer your calculus and STEM questions. We basically did our poll today, 45 minutes on the clock. We got 4 votes for Gen Chem, 2 for OChem, 2 for physics, and 4 for calculus. I decided to start off with calculus to show some love because we haven't done calc in a while. So basically did related rates, we did the squeeze theorem, we did basically the derivative of we basically did non-differentiable functions, and so now we're gonna do inverse trig. No, let's see, you said inverse functions, right? You say inverse functions or inverse trig? And then let's see the Discord here. What's gonna be the Discord here? Okay, so, and guys, remember, the best way to ask questions is to join in on the Discord here. So I basically see it was inverse functions, and let's see here, you know what I mean? Like, I wonder if I have any problems here for inverse functions. Guys, I'm gonna go ahead and pull up some inverse functions here, but in the meantime, remember, you can sign up for tutoring by signing up at the link in my bio. Just go to engineeringminds.co and sign up for tutoring there. Okay, I'm gonna look up for some problems for inverse functions, and let's see what we have here for inverse derivatives. Sometimes I memorize problems or I can make them up on the spot, but right now I can't think of any problems for inverse that I can make up on the spot, guys. So we're going to try to lock in for this together. How do you retain information for every single subject? The short answer is I do a lot of self-studying. Most people hate school, but I actually love studying for fun. So sometimes when I'm bored, instead of just being bored, I actually like to study for fun. So that's one answer. The other answer is, I don't know everything. People sometimes think that, like, oh, how do you know everything? I only know like some small select things for my major. So this is my major and I'm really passionate about my major. So whenever you make it fun, I try to make it fun. So whenever you make it fun, that's how you actually start like learning faster, because then you can actually enjoy doing it. So my hobby is studying, which most people hate studying, but studying is my hobby. Okay, because to me, studying feels like a video game. Okay, got some derivatives of inverse functions and logarithms here. And let's see what we're gonna do here. Right, here's gonna be some examples here. I don't know how to make it fun. Well, you're still here on the live. You've been here for quite some time, so we're gonna do our best to make it fun. For me, what makes it fun is the physics. And I try to make it fun with analogies. So if you're taking OChem, you already know that, like, I like to make OChem fun by saying that, like, oh, they go to a party and then the nucleophile gets attracted to the electrophile. Kind of like that. Do whatever it takes to make it fun. Make your own names, make your own rules. Try to contemplate, where is it used in real life? Because if you can see math in real life, oh, that's how it starts to get fun all of a sudden. So where is math used in real life, guys? I feel like math is used in real life everywhere. I feel like math is real life. I feel like we're not even made of particles, we're made of math, honestly. If you think about it, like, we're basically just equations in a way. And if you think that's a little esoteric, maybe, but that's kind of like how I feel about it, you know, in the sense that like, you know, the Big Bang Theory, you know, that's just a theory. Okay, so guys, here we have our functions. Here we have our inverse functions. 1/2 x plus 1, and then inverse of x, inverse of f equals 2x minus 2. Okay, Dr. Drew is getting existential. Yeah, I use chemistry and physics all the time in anesthesia. Exactly. See, in anesthesia, there's going to be tons of chemistry and physics, right? Okay, so we basically have these two functions here. And notice that if we take the derivative of these two functions, okay, let's go ahead and take the derivative of f of x here. F prime of x here. Guys, what's the derivative of, oh, I call that f prime. I meant to call this f inverse. My apologies. So f prime of x is equal to what here? F prime of x on the left-hand side. And what's the derivative of the inverse function here? So let's take the derivative of f inverse of x. Okay, so on the left-hand side, this is going to be equal to 1/2. And on the right-hand side, this is going to be equal to 2. So notice that they're going to be reciprocals here. Okay, so the derivatives are reciprocals of one another. So that's the first thing you have to understand about inverse functions. Okay, so what questions can I help clarify about inverse functions? Okay, that's going to be the first thing. What's something that I can help clarify regarding inverse functions? Should we just do some examples? Should we just do some examples here? I'm going to just do some examples here. So, for example, let's say I have f of x, okay, equals x cubed minus 2. And I want the derivative of the inverse of f, okay, at x equals f of 2. So we have to do a step-by-step process. We're going to do a step-by-step process here. We're going to let our function here, we got to basically solve for the derivative of the, we got to basically do our inverse function. So guys, how do we get inverse functions? This is back to algebra. So someone said, I think it was Bubba said, you know what, I'm pretty good at the calculus, but sometimes I just forget the algebra. That's 100% true. So remember your algebra, guys. Remember in algebra class, how do we get inverse functions? So first, I'm going to turn this into a y, and then I'm going to turn this equal to x cubed minus 2. Okay? So an inverse function means that I'm going to basically flip-flop these. So I'm going to flip-flop my x and my y's. So I'm going to flip-flop my y here. I'm going to put this as an x is equal to y, okay, y cubed. So my y here, now this is my inverse function. So guys, this is my function, and now y here is now my inverse function. That's what I want. So I have to solve this algebraically here, which your professors are going to say, hey, you should know this by now. It doesn't mean you should know this by now. It just means that maybe you forgot. Maybe you just kind of forgot how to solve for inverse functions here. And so I have basically y equals the cube root x minus 2 to the 1 over 3. So this is my inverse function. So I basically define my inverse function is equal to x minus 2 to the 1 over 3 here, okay? Guys, let me know if this is making sense here so far. Does everyone agree with what I did so far? Does everyone agree with what I did? Okay, does everyone agree with what I did here? Now I can differentiate this function. Okay, now I can differentiate this function. It should be, okay, it should be practically differentiable here, okay? Okay, so just double checking here, I took the cube root of both sides, okay? So now I can take, so this is my inverse function, I can take the derivative of my inverse function, which is going to be basically my power rule, so I'm going to basically bring that down. So what would that be here, guys? What would the derivative here of this function here be? I'm going to use my power rule, I'm going to do 1/3 x minus 2 to the minus 2/3, okay? And so that's going to be my power rule here, times my derivative of my inside, that's already there. So there we go. So if we do that at x equals 2, because remember it said do it at x equals 2, or what did it say? F of 2. So now that's f of 2. Really, that just means that is my f of 2. So let's see here. So f of 2 here, that should be, wait a second guys, hold on a second. F of 2 should be, this is my 248 minus 2. F of 2 is 248, x equals f of 2. Plug this in here, because I got 0 here, so I don't think it's 0. Inverse of x equals 6. Oh, did I say 2 or 6? Oh, they said at x equals 6, chat. They said at x equals 6. Let's go back for a second. I think I confused the previous one. It's going to be at x equals 6. Okay, so at x equals 6, I got to plug that into my original f of x. So I got to plug that one into my original f of x. So I'm going to plug that into my f of x here is a, here, 6 cubed minus 2. 6 cubed minus 2, which is a 6 times 6, okay, which is a 36 times another 6 minus 2. So I gotta do 36 times the 6. There's gonna be 1/8 plus 3, 216 minus 2. I got 214. That doesn't quite feel right either. Hold on a sec. What if I plug it over here? Guys, maybe I'm gonna try plugging it over here because something feels off. I'm gonna plug in my 6 over here, and I'm gonna do basically my 1/3, okay, times my x minus 2. And my x again was my 6. Okay, 6 minus 2. Let's try one more time. 6 minus 2 is -2/3, which is gonna be, okay, 1/3 times 4 to the 2/3, -2/3, which is basically a 1/3 times 1/4 to the 2/3, which is going to be 1/3 times, let's see, that should be 4, I believe. 4 squared is basically 4 squared times 4 to the 1/3. So 4 to the 1/3, so that's 16. So 4 to the cube root of 4. It's the cube root of 4. This is gonna be that's gonna be a point something. Guys, I tried to not use a calculator here, but let's just try it out. 4 to the 1/3. I think I made a typo here. I think I made a typo right here. I know this should be a 1/3 times 4. Okay, I know this should be a 1/12. I think I made a typo somewhere. There's going to be some kind of typo here. Let me check my derivative. But guys, how's this making sense so far? If I, ignoring the math mistake somewhere, there's a math mistake somewhere. Ignoring the math mistake, is this generally making sense here? We have to basically apply the function here, x cubed minus 2. And then we basically solve for the inverse function first. Basically solve for the inverse function first. That's going to be allowing us to differentiate that with respect to x here. So if we differentiate with respect to x, it's going to give us our new differentiable function. Okay, and then if we have that, that's going to basically allow us to calculate that. Now, again, I think I made some kind of math error over here. I'm just not able to quite see that yet. Okay, this should be a 16 times a should be basically a 1 over 3 times 4. It should be basically a 1 over 12. Okay? How are we doing here? How are we doing here? Guys, let's do another poll, and let's see how we're doing here, and see if this is helpful, guys. So if this is helpful, drop a like, drop a thumbs up, and hit that follow button. Let's see how we're doing in terms of what topic we should focus on. So let's get up that poll one more time. This time I'm only going to do 3 minutes on the clock. So last time we got General Chem 2 votes and Physics 4 votes as well. So let's do 3 minutes on the clock. Let's see what people want to focus on. So same topic, same question, 3 minutes on the clock. What should we do next here? Should we continue with calculus for a few more minutes, or should we just jump into Gen Chem? Because I know people wanted to do Gen Chem. So if you want to do Gen Chem, pick A. If you want to do OChem, select B. Physics, C, and then calculus, D. Okay, so far we got 2 votes for OChem. So now we got more votes for OChem this time. And guys, don't forget, if you do need tutoring, remember you can sign up for the session at the link in my bio. Just go to engineeringminds.co. You can also join the Discord, which is totally free, and ask your questions online. Guys, so far we got 5.6k likes and 6 new followers. Thank you so much for all the likes and the love. And yeah, guys, make sure you hit that follow button because I go live every single week. We're going to keep it going. 50 more minutes on the clock. Got 50 more minutes on the clock. So whatever is going to be the winner, we got to do next. Now, the only problem is a lot of people that voted earlier are no longer here. So if you want to still do Gen Chem, make sure you vote on the top left-hand side of your screen. 2 minutes left on the clock. How's everyone doing today, chat? How's everyone doing, my friends? Are you guys cooking this semester or getting cooked? Are you guys cooking or getting cooked? Interesting. We got 3 votes for Gen Chem and OChem once again. So we're probably going to switch gears here to chemistry. And guys, let's see what are the topics we should go over here for Gen Chem versus OChem. So earlier, let's see what we said. Earlier, we said, I saw someone say colligative properties. I saw someone ask about Hess's law as well. And so what topics should we do? Should we do colligative properties or Hess's law? Or should we do OChem? So I'm gonna keep that poll active, but keep in mind that I'm gonna do another poll very shortly. So I'm gonna do colligative properties. I'm gonna do Hess's law. And then I'm going to do colligative properties, which I haven't taught that in a while, so that's going to be fun for me. It's going to be Gen Chem, and then should we do SN1, SN2, E1, E2, Organic Chem, or other? Okay. So let's see, guys. We're still doing the first poll, so 10 seconds left. You got 10 more seconds to vote for the next topic. Is it going to be OChem, Gen Chem, Math, or Physics? And again, we got equal votes again for Gen Chem and Organic Chem this time. Minors chemistry teacher is 18 days behind grading. Oh no. Nor says Hess's law. I just realized how behind I am. I'm so hopping off. Okay, guys. Thanks for voting. We got chemistry and organic chemistry. So let's do another poll here. So let's do another poll so we can pick the next topic. And we're going to go 50 more minutes on the clock. So we're going to just start a new poll. So think about which topic we should do next. Is it going to be A, Hess's law, B, colligative properties, C, SN1, SN2, E1, E2, or D, other? Make sure you vote up on the top left-hand side of your screen. Guys, thank you so much for joining today. It's been 1 hour and 10 minutes. If you missed any part of this live, don't even worry because we are doing we are recording this live today and posting this right on my YouTube channel right after this. And so anyone that is new, welcome into the chat. My name is Dr. Andrew Sanchez. If you're new, comment the word new so that we know that you're new. And if you've been here before, comment the lock in emoji because you know that we are locked in. Once again, my name is Dr. Andrew Sanchez, PhD in Chemical Engineering. I go live every single week, Monday through Thursday, to answer your questions for STEM, whether it's mathematics, chemistry, physics, or more. So make sure you hit that follow button so you don't miss another live. Guys, as you can see, here's my website. Shouts out Jackson down in the chat, aka Huel Academy, for working on the website. Everyone do me a big favor and comment W Jackson for the website here. Okay, guys, so this is Engineering Minds, where you can engineer your mind. So if you need tutoring, I got you for various STEM subjects: math, physics, chemistry. If you need help with algebra, trig, pre-calculus, calculus 1, 2, and 3, general chemistry, AP chemistry, organic chemistry, physics, and engineering, I got you covered. Just sign up for a free consultation call at the link in my bio. The lock-in emoji, the lock-in. And yeah, guys, so super excited to be presenting this here today. And guys, make sure you join the Discord. It's 100% free. This is the best place for you to ask questions, meet other STEM members, and get inspired to study STEM subjects. Okay, there's going to be STEM majors, engineers, and future doctors in there, my friends. Guys, make sure you vote for the poll on the top left-hand side of your screen. We got a couple seconds left here we have 60 seconds left for the next topic here. We're going to go for another 45 minutes today. And the options are A, Hess's law for general chemistry, B, colligative properties for general chemistry, C, SN1, SN2, E1, E2 for organic chem, or D, another topic that you can comment down below. And yeah, guys, we are going to get started on the last section for today, but don't worry, I will be back next week to continue the live. So once again, make sure you hit that follow button. And once again, we have an equal vote for Gen Chem and OChem. Only 15 seconds left, so make sure you invite your friends, tell them to vote. And 10 seconds left, guys and gals. All right, so I think what we're going to do is this. Because Gen Chem won the last vote, and right now we have equal between Gen Chem and OChem. Here's going to be the next plan. What we're going to do is Hess's law for about 30 minutes, and then SN1, SN2 for about 30 minutes as well. So let's write down the plan, or roughly 20 minutes, and let's see if everyone agrees with that. We're going to do thermo and Hess's law. Okay, for about 15, let's say 20 minutes on the clock, and then we're gonna do OChem, SN1, SN2 for the next 20 minutes. So guys, if that is a good plan, go ahead and drop a thumbs up or a fire or a party emoji. So please stick around if you want to review Hess's law from general chemistry. And then if you want to do organic chemistry, come back in about 15-20 minutes. If that's a good plan, go ahead and drop a thumbs up, fire emoji. Thank you, Italy. Awesome, guys. So we're going to lock in for thermo for the next 15-20 minutes. Okay, so remember, this is a topic that we have talked about in the past, so make sure you check out the YouTube videos that go over this on the channel, and we're going to talk about Hess's law. So, Hess's law, let's go ahead and pull that up. Bear with me 1 sec. So I have my textbook here. We're going to review Hess's law for 15-20 minutes, do an example, and then we're going to do SN1, SN2, E1, E2. Okay, so I'm going to pull up my equations here for Hess's law. And remember, Hess's law is nothing more than just going through the energy transformations, right? Okay. Where is my Hess's law equations? Elementary. Here we go. Okay, so guys, I'm going to give you a set of equations. Which one did I do last time? That one was pretty fun. Okay, I'm gonna do. I don't want to do like a crazy one. Okay. Okay, we're gonna do a medium one. I don't want to do a super hard one because sometimes these take forever. So guys, here's going to be an example for Hess's law. So one more time, if you're ready to lock in for Hess's law, get off your bed, get out your notes, and get out your calculators because we're about to lock in together. And I promise if you follow along and actually do the calculations with me, you're going to learn more in the next 10-15 minutes than you have all semester long. Okay guys, if that's a good idea, if we're ready to lock in for Hess's law, let's see some more lock-in and fire emojis so I can know that we are good to go. So let's see some fire emojis here. Okay, because fire is going to stand for our thermodynamics equations. And perfect. So this is going to be our first reaction here. So it says C2H5 plus 5 halves O2 gives us 2CO2 gas plus H2O liquid. So this is a given reaction here. So we have to basically use the delta H given here. And it's given as, okay, in kilojoules, it's given as negative 1300 kilojoules. All right. And this is going to be negative 1300 kilojoules here, right? Absolutely, we can do chemical equilibrium, but the next topic we're going to do, Twin, is going to be Hess's law. Okay, and then basically have this as our next reaction here. Carbon solid plus O2 gas is going to be CO2. Okay, and then this one's going to give us another delta H. Okay, this delta H is negative 394. So what do you think we have to do? What do you think we have to do, chat? Okay, then finally we have H2 gas plus 1/2 O2 gas gives us H2O liquid. So as you can see, we have this data here. Again, this is Hess's law where the data is given here with the delta H on the side. So hopefully everyone can see the delta H is on the side. This is equation 1, this is equation 2, and this is equation 3. Now, they say that we need to calculate the delta H for the following reaction. It's going to say 2 carbon solid plus H2 gas reacts to form C2H2 gas. Okay, now we need to solve the delta H here. So what's the first thing we gotta do? What's the very first thing we gotta do? Kevin says times 2. Kevin says times 2. Okay, so I'm gonna look on this side. This is my final reaction here. This is what I want here. And here's what I have. So I gotta convert what I have into what I want. So how am I gonna do that? How am I gonna do that? Well, I noticed that I have C2H2 as the product. So which one of these equations has the product? This is gonna be equation 1, this is gonna be equation 2, this is gonna be equation 3. So which one of these equations has the product? It's gonna be C2H2. I gotta look on the equations here. I put a C2H5 here, so none of them had the product, chat. So this is going to be C2H2. There we go. So now I have C2H2 right over here. So I know I gotta take this equation and I gotta carefully flip this entire reaction here. So I'm gonna flip the entire reaction and carefully write that out. But before I do that, I gotta carefully do negative here. So for example, I'm gonna take my reactants and turn them into products. My products are going to become reactants. So first I'm going to have 2 CO2. I have 2 CO2, okay, gas plus H2O liquid. So my products became my reactants. Now my reactants are going to become products here. And now I'm going to have C2H2 plus 5 halves O2. Okay, plus 5 halves O2. Okay, and so when I take a flip, I gotta do the negative of that value here. So I'm gonna take negative 1300, which is gonna give me a positive 1300. Let me do a quick pause here. Let me just do a quick check. Are we doing okay so far? If this is making sense and we're still following along, drop a thumbs up. If this is totally confusing, drop that crying emoji or that pot emoji to let me know that you got cooked. Do I need to take chemistry for mechanical engineering? Yes, I think you do. I think you need at least 1 year or half a year of Gen Chem. Okay, because you gotta do thermo. You gotta do thermo. Okay, tree work says crying. So tree work, here's our product. Here's what we want. Okay, this is what we want. What we want. And we have a puzzle here. So on the top side is a puzzle that we gotta solve the puzzle and flip the product here to give us our final reactant here. So now that I flipped the bottom side, now I have this part here. Okay, so I'm not done yet. I'm not done yet. So if you're not getting it yet, that's fine. But just make sure you get out your notes and follow along and copy what I'm doing, and it's gonna suddenly click. Okay, but what's the problem here? The problem is I still don't have H2 and 2C, and I also want to get rid of these and these. Okay, so how am I going to get rid of these? Well, I noticed that I have H2 over here and H2 over here, and I have my water over here that can cancel out with maybe some of my waters. Let's see here. So there's going to be my water on this side, but then I have water on this side. So if I have water on this side here and water on this side, I'm going to add this equation here. Okay, I'm going to add this equation. That's going to give me, okay, H2. Okay, I'm going to use H2 gas plus 1/2 O2 gas reacts to form H2O liquid. So this time I didn't flip anything, I just combined it. Okay, I didn't flip anything, I just combined it. Okay, why? Because now I can add my negative 286 and I can cancel out my H2O liquid and my H2O liquid, which is good because on this expression I don't have any H2O. So I want to cancel out my H2O here, and I have my 2CO2 that I want to get rid of here, and my 5/2 O2 on this side. Okay, what's the last thing I gotta do here? What's the next thing I gotta do here? Does anyone know? Okay, if this is making sense, let's see that thumbs up. If you're still confused, let's see some more crying emojis. Let's see some more pots. Okay, let's see some more thumbs ups if this is making sense. Yes, this is Gen Chem here. We're doing Hess's Law currently. Hess's Law for about 15 more minutes, and then we'll switch gears to OChem. Okay, so I have my C2H2, so that's good. So I'm going to put a check mark right here because I have that. I got rid of my water here, so that's good. But again, the problem, and I have this, so that's good too. So let's highlight that one. Okay, we're making progress here. I have my H2 gas, so that's good. The problem is here I have a 1/2 O2 and a 1/2 O2. So I gotta add my carbon here on the left hand side. I'm gonna basically add this by 2. So I'm gonna take 2 times my second equation. I'm gonna do 2 times my second equation. So let's multiply my second equation by 2. So I have a 2 carbon solid. Why am I doing this? Because I want to cancel out my 2 oxygens, okay, and my 2 CO2s here, but I also have to multiply the delta H value by 2. Okay, so now I have my 2 carbon here, and that's good. That was my third product. That's really good here. I have this, which matches that, but I have too much stuff here. I have too much stuff that I want to get rid of. Well, I have a 5/2 O2 minus a 1/2 O2. So I'm going to cancel out 1/2 O2. That's going to give me 4/2 O2. So 4/2 is a 2 O2. So 2 O2 cancels out with that 2 O2. And my 2 CO2 cancels out with my 2 CO2. So at the end of the day, I got what I wanted. See how I did a puzzle here? I got my 2C solid, which is what I wanted here, plus my H2 gas, and that's going to react to form my 2CH2. That is exactly what I wanted. But the last thing I have to do, chat, is I have to add up all my numbers right over here. So I'm going to add up all my delta H's. Guys, is this making sense, or am I totally confusing you here? I'm going to add up all these values here. This is a negative 1300 minus Okay, minus a negative 1300 minus a 286. I did not change that whatsoever. And then I did a plus 2 times a negative 394. If this is not making sense, make sure you rewatch the video later today that I'll post on my YouTube channel. And we're going to calculate this out. I'm going to calculate this out. I'm going to do negative 1300, which is a positive 1300, minus a 286, plus a 2 times a negative 394. I got 256. So I got 256. That's my final answer. Guys, if this made sense, let's see those thumbs ups emojis. Let's see those thumbs ups. Thumbs up emojis. And if you're still a little bit confused, that's totally fine. But just let me know with a crying emoji if you got a little bit lost here. This is how we do Hess's law here. Val, thank you for the follow. Treework, thank you for the follow. Okay, so far not seeing too many questions so far. So I think I'm gonna go ahead and switch gears here soon to OChem. Okay, got a lot of requests for OChem today, so I think it's time for OChem in the next 60 seconds. I'm gonna wait just 60 more seconds if there's any more last minute questions here. Okay guys, so if we're gonna switch to organic chemistry, SN1, SN2, E1, E2, if that's a good topic, go ahead and drop a thumbs up down below if you want to do organic chemistry today. If organic chemistry, SN1, SN2, E1, E2 is a good topic, let's see a thumbs up down below. Thank you for your patience, Bubba. You're still here. Ready for some organic chemistry? All right. Some of you have been patiently waiting for 1 hour and 26 minutes. Okay, guys. Awesome. So, guys, we're going to go ahead and do that next. Twin, unfortunately, I got to switch it to OChem, so if you got to do titrations, you got to do that next time, okay? But don't worry, I will be back next week to continue that topic here. So, guys, the next topic is going to be organic chem. Remember, we're going to do SN1, SN2, E1, E2. So, guys, what topics can I help clarify for these topics? Should we do mechanisms? Should we do predict the products? Should we do the differences between each? Should we do primary versus secondary versus tertiary? What exactly about SN1, SN2, E1, E2 should we help clarify here? Maybe let's do a quick review for our SN2 reactions. Maybe let's do a quick review for our SN2. So let's start by doing a quick review for our SN2 reactions. If I have a secondary leaving group here, and then I'm going to react it with a nucleophile, then I'm going to do a concerted. Okay, let's do a quick pop quiz. So how are we going to do a quick pop quiz? So someone said predict the products. Someone said confusing Gen Chem 1, but I know Orgo is hard. Seeing will probably help me get into OChem. Absolutely. Okay, so guys, we're going to do SN2. So I'm going to do a pop quiz here. Okay, SN2 is going to be either concerted or stepwise. Okay. Process. So SN2 is either going to be concerted or stepwise. We're going to have our nucleophilic attack and loss of leaving group step. Okay, so if you think that SN2 is a concerted process, you're going to vote for a happy face emoji. And if you think that it's a stepwise process, you're going to vote for a crying emoji. So got 3 more seconds to think about it. And 60 seconds on the clock starting now. So SN2 is going to be a mechanism where we take our loss of leaving group step and do a nucleophilic attack. So if our leaving group leaves and our nucleophile attacks, is that going to be SN1? Is that going to be a stepwise process or concerted process? If you think it's a concerted process, you're going to vote for a happy face emoji. If you think it's a stepwise process where we go step by step by step, you're going to vote for a crying emoji. Guys, anyone that's just joining in, we are switching gears here to organic chem, and that's really interesting. It was really quiet for a while for Gen Chem today. Now all of a sudden, the OChem people have arrived. Okay, and if anyone needs any help for organic chemistry, remember I got you covered. I do private tutoring and group tutoring where you can sign up for a free consultation call at the link in my bio. Okay, so guys, very good. We got 4 votes, 3 seconds left. 3, 2, 1. Okay, very good. So we got 4 votes for a concerted process, and if you did not vote, that's totally fine. Just pick a random option here. So the answer was concerted. So SN2 is going to be a concerted process, and concerted means that it's going to happen in one fell swoop. So the first process we're going to do here is our loss of leaving group step. Okay, our loss of leaving group step, and then we're going to do our nucleophilic attack right over here. So that's going to be our loss of leaving group step and our nucleophilic attack. Okay, this is going to be a backside attack. So the backside attack is going to basically come in from the back and do that SN2 rearrangement just like that. Okay, and we're going to basically have our nucleophile come on this side here. So if this made sense and everyone is agreeing and following along, do me a big favor and drop a thumbs up. Okay, if you're understanding what I'm saying so far about SN2 mechanisms, go ahead and drop a thumbs up to make sure we're all on the same page here. And if you have any questions, go ahead and drop them down below. Okay, yeah, absolutely. Have a Discord twin where you can join in the link in bio. Just tap my link in bio or go to engineeringminds.co, the same website you see on the top. Click that link that says join Discord. It's 100% free, and that's how we're gonna do. And then that's how you can ask me questions for OChem. Okay, so that's gonna be our SN2 mechanism here. Now we're gonna do another one here. Is gonna be SN1. So same question is gonna be SN1 is gonna be a stepwise or concerted. Okay, so SN1 is going to be stepwise or concerted. Okay, 60 seconds on the clock. So if you think SN1 is a concerted process, you're going to vote for a happy face emoji. If you think that SN1 is a stepwise process, you're going to vote for a crying emoji. All right, very good. We got 3 votes so far for crying. Bubba, good job. Bubba, Eliza, Jamie. Good job, everyone. So let's do our SN1 mechanism. It's going to be the same idea here where we're going to have a loss of leaving group step. And remember, someone asked me earlier, how do we make it fun? So organic chemistry is actually a perfect opportunity to make this fun because this is going to be a step-by-step process. If you don't know, just guess. If you don't know, just guess. Okay, we got to do a step-by-step process. Okay. And this is something that I go over every single week in my OChem group course. So guys, if you need help with organic chemistry, do not be afraid to reach out for help. You can sign up for a free consultation call or see all the information at the link in bio. Guys, we got 4 votes for stepwise. So that is correct. Everyone is cooking it up today. Everyone go ahead and drop some party emojis and some thumbs ups because y'all are cooking it up today. It's going to be a stepwise process here where the first step is going to be the loss of leaving group step. So if you want to enjoy OChem, you're going to pretend that this is the breakup phase. Step 1 is going to be the loss of leaving group. This is going to be the breakup. Okay, so the breakup phase occurs and we generate a carbocation intermediate. I'm going to do another question. We're going to generate a carbocation. Okay, if you want to make it fun, this is going to be the breakup phase. And so there's going to be a carbocation intermediate. The carbocation here. Another question. Thank you, Bubba. Appreciate you. Okay, we got another question here. The carbocation is either going to be there we go, primary or tertiary. So if you think it's going to be primary, you're going to vote for a happy face emoji. If you think it's going to be tertiary, you're going to vote for a crying emoji. 60 seconds on the clock starting right about now. Okay, guys, we're going over SN1, SN2. Thank you, Jamie, for the you're awesome. No you, no you. How does one not like OChem? It was my second favorite class in college. Exactly, right? Pistachio says crying. Good job. Okay, guys, so we have this loss of leaving group step. Okay, think of the loss of leaving group step as a breakup phase here. So the leaving group left the compound and generated our carbocation. Is it going to be primary or tertiary? If you vote primary, make sure you vote for a happy face emoji. If you think it's tertiary, vote for that crying emoji. And if you don't know, just pick a guess. There are no wrong answers here. Okay, good job, everyone. Eliza, pistachio. Jamie said crying. Boba says crying. Emily says happy. If you said crying or happy face, why did you choose that answer? Okay, if you think it's primary, why do you think it's primary? If you think it's tertiary, why do you think it's tertiary? Okay, 3 seconds left. And boom, we got another 5 votes. Everyone is cooking that up. If you voted for a crying emoji, you are correct. So good job, everyone. And if you voted for happy face, don't worry. This is just for funsies here. So the correct answer here is tertiary. And how do I know it's tertiary? Because I see that my carbon atom here, my carbocation has basically 1, 2, 3 R groups here onto the side. Okay, and so tertiary means that we're going to represent that with a 3rd degree here. So that means we have 3 R groups, and so therefore that is tertiary. Meanwhile, let's continue the storyline where we had our breakup phase, and meanwhile, we're going to have what I like to call the ribosome, which is represented by the nucleophile, is going to come in and basically take advantage of the situation here. And this is going to be called our nucleophilic attack. This is going to be called our nucleophilic attack phase, which I like to call the rebound phase. This is called the nucleophilic attack. I like to call this the rebound phase. So as soon as you start to realize that organic chemistry is actually the study of literally chemistry, haha, then that's going to start to make it more fun for you. And you're going to see that everything is all about who likes who has a crush on who, and who's going to be broken up and who's going to be basically together at the end of the reaction here. So that is step 1. That is SN1, is stepwise reaction here. Okay, happy Moles Day. Is today Moles Day? What is Moles Day? 6? What is today? 10/23? Wait, what is Moles Day? Why is it 022 times 10 to the 23? Oh my. Happy Moles Day, everybody. Okay, happy Moles Day. I did not know this. I did not know this. How do I get this and not physics? So if you get this but not physics, I'm assuming that you're in a science major, okay? If you're a science major, you're going to be better at things like biology, chemistry, and memorizing. If you're an engineering major, you're going to be better at math and physics. I'm an engineering major, so I prefer math and physics. But if you struggle with math and physics, don't worry, I got you for that as well. I can definitely try to make it fun for physics too. Okay, Avogadro the goat. I like anatomy the most. See, I've never taken anatomy, but I feel like I would struggle a lot, guys, because I'm really, really bad at memorizing. Okay, so that is SN1, SN2. Guys, we gotta go move on to E1, E2. Let me know if there's any last minute questions about SN1, SN2. Otherwise, we're gonna move on to E1, E2. Okay, E1, E2 is some of my favorites to talk about because the analogies are super, super fun. Okay, the analogies for E1, E2 are super, super fun. So guys, remember, try to make it as fun as possible. That's how you're gonna basically remember all these processes here. Okay, let's start with E2 here. So same question for you, my friends. Is E2 gonna be stepwise or concerted? E2 is gonna be stepwise or concerted? Stepwise or concerted here? Concerted here. Okay, so same question, my friends. We gotta move on quickly. Is E2 gonna be stepwise? Vote for a happy face emoji. And if you think it's concerted, vote for a crying emoji. And remember, if you're missing any part of this, I am recording this. You can rewatch on my YouTube channel later today when I post it. Okay. 60 seconds on the clock starting right now. Let's see what you think about E2. And whatever you vote for, please let me know what is your thought process. What is your logic behind that? If you say that it's Stepwise. Why would you say stepwise? If you think that it's concerted, why would you say it's concerted? Okay, so here we're going to have a similar storyline. Here's going to be our couple. Okay, and our couple's going to be chilling, hanging out at the party with our leaving group here, right? So our leaving group here is hanging out at the party. And meanwhile, our base is going to act as the basically the Riz boy that's going to basically come in here. So let's see the results so far. We got 15 seconds left on the clock. If you don't know, pick a random guess. If you don't know, just pick a random guess. There are no points here. 5 seconds left. We got 0 votes for happy face, and we got 3 votes for concerted here. Okay, very good. So E2 is going to go ahead and be a concerted process. So guys, if you voted for concerted, then you are correct. Good job, everyone. Good job if you voted here. So here's going to be our E2 mechanism here. So E2 is concerted. And remember, our compounds are going to be basically chilling, hanging out at the party. And so one day our leaving group is basically going to just kind of just hang out here. Okay, and then our base is going to come in a concerted step. The base is going to go ahead and attack the proton here. Okay, we're going to attack the proton over on this side here. Okay, so it's kind of like they stole, like someone stole, you know, that person's purse or some kind of belonging here. Okay, exactly. Noodle says 2 reactions are concerted, 1 reactions are stepwise. Okay, no wait, yeah, 2 reactions are concerted, 1 reactions are stepwise. Okay, good job, good job. All right, and meanwhile, our leaving group, our H proton here basically kind of just created a double bond here, and that's going to facilitate the loss of leaving group steps. So this is going to happen in a stepwise fashion, I mean a concerted fashion. So concerted meaning concerto, in a nice and, you know, angelic dance. It's a dance, it's a mingling. That's why it's a very, you know, very R-rated mingling here. And so our base is going to be the proton transfer step. Okay, remember proton transfer is basically an acid-base reaction. And then our loss of leaving group step. Guys, what are some good examples of good leaving groups? What is a good example of a good leaving group? Comment down below. Okay, and on the right-hand side, we've generated an alkene group. So E reactions always create alkene double bonds. Alkenes are double bonds. Okay, so everyone, if you didn't know that by now, everyone write that down in your notes or comment it out down below so you can lock it in your memory here. Everyone comment this down below. E reactions generate alkenes. E reactions generate alkenes. Okay, everyone write that down 3 times or comment it down 3 times. Everyone comment E reactions generate alkenes 3 times so that way you can commit it to memory. And so alkenes again are double bonds. Okay, so everyone write this down. E reactions generate alkenes. Cool, cool, cool. There you go. There you go, Pistachio. So Pistachio said that. And then very good. Bubba said BR here. Bubba said BR is a good leaving group. So guys, let's talk about good leaving groups real quick. So Bubba said BR. Why is BR a good leaving group? Why is BR a good leaving group here? Let's make a list here. BR is a good leaving group. What are some other good leaving groups here? Good job, everyone. E reactions generate alkenes. E reactions make double bonds. Exactly. As soon as you see double bonds, boom. E mechanism here. Okay. OTS. Okay, let's put OTS here. OTS is a good leaving group. What about what other good leaving groups might we have here? So for example, what if I give you a reaction here? What if I give a reaction here that's going to be our single bond chlorine like this? Okay. What about chlorine? Is chlorine a good leaving group? There you go. ICl. All the halogens are typically really, really good leaving groups because they're going to be filling their octet. Okay, they're going to be satisfied in terms of the octet rule. Okay, so our leaving group chlorine is going to leave here while our base, let's say our nucleophile is, for example, hydroxide. Hydroxide is going to be a strong base here. So remember, hydroxide is a strong base. Hydroxide is a strong base. It's going to attack this proton and create this, and so that's how we have our, again, our alkene in this E reaction here. Okay, in this alkane E reaction. Now, I really want to point out, chat. Okay, any questions here? Any questions here? Because we're almost out of time. But I want to point out, those of you that are in the Discord, I've already dropped a table that I've been using every single time. So if you're in the Discord, you're going to go to the hashtag chemistry channel. You're going to go to the hashtag chemistry channel, and then I'm going to go up to this table here that I already dropped this in the hashtag chemistry channel. So if you want to join the Discord, it's totally free. Just join in there. And this table is going to be super useful, to determine if you have an SN1, SN2, E1, or E2 mechanism. You're probably going to have a table like this that your professor will give you or in your textbook. But I went ahead and dropped it in the Discord because I want people to have easy access to that. So we're going to go ahead and see and analyze how to read this table. Okay, and we're going to go ahead and analyze this table and one by one figure out what are our different criteria. And the way we do the criteria, I want you to ask yourself, for every reaction, I want you to always ask yourself, what is my nucleophile, number one? What is my nucleophile or base? Number two, what is my leaving group? Number two, what is my leaving group? And number three, is it primary, secondary, or tertiary? So every time you see a reaction, always ask those three questions. What is my leaving group or substrate? What is my nucleophile or base? And is it primary, secondary, or tertiary? Okay, let's do an example. So suppose I gave you something like hydroxide. Okay, suppose I gave you hydroxide. So you're going to go to this table and identify where in this third section right over here. Okay, and is hydroxide a strong nucleophile or a strong base? Okay, is it a strong nucleophile or a strong base? Well, technically it can be both. So because hydroxide can act and function as either a nucleophile or a base, we're going to do a different test. We have to test where's our leaving group, and we have three different criteria. We have three different options here. If our leaving group is primary, we're going to do E2 as the minor product, and E2 is going to be the minor product, and SN2 is going to be the major product here. Okay, so if we have a strong base that's primary, then we're going to have two products. The SN2 product is going to be the major product, and E2 is going to be the minor product here. Okay, now if it's secondary, however, if it's secondary, we're going to have this be E2 as a major product, and SN2 will be minor here. Okay, I just joined and don't want to interrupt. Yeah, absolutely, Sean. I gotta check those. Yeah, drop it in the Discord and then I'll answer you as soon as I can. And then last but not least, we're going to have tertiary here is going to be E2 here. Okay, so we're going to try to do some examples here. But before we do any examples, are there any questions about how to read this table? Again, if you want to download this table, you probably have one that your professors will give you or in your textbook. But again, I went ahead and dropped it in the Discord so you can have access for that. Okay. So yes, these are going to be all our reactions for SN1, SN2. And again, if you missed any part of this, I am recording this and I'll post this tonight on my YouTube channel. Okay, guys, we're running out of time today, so I'm going to go quickly here, do a couple examples here. Okay, I'm going to do a couple examples so we can see our E1 versus E2 here. Now, we're going to do our tertiary example one more time. We're going to do our tertiary example. So I'm going to have my nucleophile. Okay, this time I'm going to do, say, I'm going to do like iodine here. And remember, every time you see E1, E2, SN1, SN2, I want you to ask three things. I want you to ask, number one, what is my leaving group? Number two, what is my nucleophile electrophile? And then number three, is it primary, secondary, or tertiary? let's say I give you NaOH here. Okay, number one, first things first, what is my leaving group here? What's going to be my leaving group, chat? Everyone comment down below, what's the leaving group here? Okay. Okay, everyone comment down below, what's the leaving group and what's going to be my nucleophile? What's going to be the leaving group and what's going to be the nucleophile, chat? Okay, I have basically this compound here. Okay, and then I have iodine here. So iodine here is going to be a halogen. And remember, halogens are typically good leaving groups here. Okay, halogens are typically good leaving groups. Okay, good. Pistachio says nucleophile is NaOH. All right, almost. Okay, good, good. So I'm going to label this as my leaving group. Okay, I'm going to label this as my leaving group. And then NaOH is going to basically dissociate to Na plus and OH minus. Na plus and OH minus here. So OH minus is going to be my base here. So is this a strong base or a weak base? Or what kind of base is this? Okay, let's figure this out. So I have my leaving group here and I have OH minus as my strong base here, right? And so what I'm going to do, I'm going to basically do my proton here. I'm going to have my proton right over here. And so let's see. Now we're going to go back to the table, guys. Remember, I dropped the table in the disk one. I'm going to go back to the table, and then I'm going to see this as a OH minus, okay? I see this OH minus and a strong base. So I know I'm going to be either E2 or SN2 or just E2. So now I'm going to go to my compound, and it's either going to be primary, secondary, or tertiary. If it's primary, I'm going to be E2 minor and SN2 major. And then if it's secondary, it's going to be E2 major. Okay, so I'm going to go back to my compound here. And so guys, is this primary, secondary, or tertiary? Is this going to be a primary compound, secondary, or tertiary compound? Let me know down below. I'm going to give you a hint. I'm going to say this is 1. Is this primary, secondary, or tertiary? Okay, in other words, how many R groups are we attached to here? How many different unique R groups are we going to be attached to here? Is it going to be primary, secondary, or tertiary? Well, I basically see that I have 1, 2, 3. Okay, so therefore this is going to be tertiary. Good, good, good job. Okay, this is going to be tertiary. 1, 2, 3. So very good. So now that I know this is tertiary, I'm going to go up to my table here, and then I say, okay, I have a strong base, and it's tertiary. So that means I'm going to be E2. So I'm going to do my E2 mechanism. Okay, thank you, Sean. I appreciate it. I'm going to check it out later today. So I'm going to do my E2 mechanism. So remember, my E2 is going to be a proton transfer here. Proton transfer, and then I'm going to push this down, create my double bond, and loss of the leaving group step. So kind of the same thing as we got last time, but this time we're showing exactly why. My final product is going to be this product here. Now, how do we know to get this proton and not any other proton over here? So in this case, these are all identical. Okay, these are all identical. But then we're going to have to differentiate between Markovnikov or anti versus Hoffman. Guys, I'm blinking out on the other one besides Hoffman. Hoffman versus Zaitsev. Okay, Zaitsev product versus the Hoffman product. Okay, so the Zaitsev product is going to be the more substituted alkene. Okay, everyone comment down Zaitsev is the more substituted alkene. Okay, and then everyone comment down Hoffman is the least substituted alkene. And guys, unfortunately, I'm running out of time here, so this is going to be the last thing. Substituted alkene. Substituted alkene here. So guys, our Zaitsev is going to be the more substituted alkene, and our Hoffman is the least substituted alkene. Okay, very good. So Zeit is more substituted alkene. Good, Kristen. And then our Hoffman is going to be the least substituted alkene. So guys, I went over this in my OChem group course. So if you need any help for OChem, make sure you sign up for a free consultation call. Everyone, thanks so much for joining, guys. I gotta end it in the next minute or two. Guys, thanks so much for joining here. We got 7.3K likes today, 60 new followers, and 3 new gifts. So everyone, thank you so much for your interaction. Once again, my name is Dr. Andrew, and if you guys need any help, you can join the Discord. You can sign up for tutoring at engineeringminds.co. I got you for math, chem, physics, gen chem, ochem, calc 1, 2, and 3. Guys, I'm gonna be live every single week on TikTok here, Monday through Thursday at 6 o'clock PST, 9 o'clock EST. Guys, catch me in the Discord. This is the best place for you to ask questions. Click this link that says join Discord. Make sure you introduce yourself if you're in there already and you haven't done so. We are a supportive community of STEM students, STEM majors, engineers, and future doctors. So that's going to be a super awesome community for you to have. And yeah, guys, just consider me your fellow TikTok STEM unk. Okay, I go live every single week. And again, I'm going to post all the lives here later today. So if you miss any part of the live, you want to rewatch it, just check out my YouTube channel. If you want help with synthesis, my best recommendation is either shoot me a DM or drop it down in the Discord, my friend. So make sure you join the Discord because it is 100% free. All right, my friends, thanks again so much for joining. I am going to end it here, but I will see you next Monday or on the Discord office hours tomorrow. I do exclusive office hours every single Friday on the Discord as well. So if you want more one-on-one help, that's the perfect place for you to ask questions there. So join the Discord to ask any questions to be answered on the live. Exactly, okay? It's really that simple. I basically just take whatever questions I have on the Discord, and then I answer them as soon as I see them when I have the chance, and I do them every week, okay? So absolutely, so just join the Discord, link in bio. And yeah, again, guys, introduce yourselves and be supportive. We're a supportive STEM community. So that's what I'm building out here every single week. So I struggle a lot with these subjects. Okay, and then as Jackson said, you can also submit the questions over here, the TikTok Q&A button here during the live stream as well. So that's where I can answer your questions here one by one there as well. All right, my friends, I'm going to end it. I will see y'all next Monday. Peace out, and everyone stay safe.